Okay, so this is the test review for Chapter 8, okay, where we're dealing with rational functions. First two questions you need to know, they get tweaked a little bit when I go to actual test. I know question number 1, it said, I got x and y, 1, 2, 3, 4, 5, 5, 10, 15, 20, and 25. And it says, you know, is it direct, inverse, or neither, and when appropriate, find the constant of variation. That's going to change. What's going to happen is, I don't know if question 1 will be direct or inverse, but it'll be stated what it is. This is a direct variation. Okay, I'm going to tell you that you have a direct variation, and then I'm going to just ask that you write the equation that represents the variation. Specifically, I'm going to be asking for a y equals equation. So I want to say, what does y equal in terms of x? Now, direct variation problems traditionally look like y equals kx. That's how we wrote them. The issue was always finding k. Well, if we look at the first y value, let's say it was 5. 5 would equal k times the associated x, which is 1. In this problem, it turns out that k just equals 5. Because k equals 5, I can say that y equals 5x. Now you can check that equation against any one of these. 5 times 5 is 25, and so on. You can check all of them that way. Question number 2, you're going to be given inverse. Now, question 1 might be the inverse, question 2 could be the direct. I don't remember, and I don't really care which one is which. Your job is to figure it out. But question number 2 in the example was the inverse, and so if it's 2, 3, 4, 5, and 6, and I've got 10, 12, 15, 20, and 30. Notice that as the x goes up in value, the y is dropping, okay? So it's getting smaller, which makes it an inverse. Now, inverse equations typically look like y equals k divided by x. Again, you need k so you can write this equation. Well, if I take y as, say, 20, equals k over the x, that's 3. I would times the 3 over, and I would get that k equals 60, meaning that y would equal 60 over x. Now if I want to confirm that, I just take a value like 6. If I take 60 divided by 6, I get 10. And so again, I've confirmed I have that. These are supposed to be pretty straightforward and easy to work with. But again, you're going to be told whether it's direct or inverse and asked to write the equation. All right, so question 3 and 4, we're going to get into the graphs, okay? And I asked you specifically for the domain. We'll talk about the domain here in just a second, but we have y equals x plus 2 over x minus 4. Now, in class, we always talked about finding the VA, the vertical asymptote, and the horizontal asymptote when we graph these rational functions. The same approach is used now. Even though I don't specifically tell you you have to give them, you should expect to draw them in your graph. That's part of the process. So the vertical asymptote always comes from making the denominator 0, and that occurs at 4, because 4 minus 4 would be 0. So over here at 4, I'm going to draw that vertical asymptote right there. And then horizontal asymptotes always fit into one of two categories. They can be bottom heavy or balanced. We aren't going to deal with the top heavy, so remember, bottom heavy or balanced. We just look at the x's exponents. Because these are both x to the first, this is what we call a balanced equation. So then we look out in front for the numbers that stick out in front. This is 1x over 1x. And 1 divided by 1 is 1. So the horizontal asymptote will occur here at 1. At this point, I just want to produce the graph from the calculator. So I'm going to grab my calculator, turn it on, go to y equals, and remember there's a couple options. One is to go alpha y equals, and hit enter. That'll give you the fraction, the stacked fraction. Otherwise, you need to use parentheses. X plus 2, and on bottom, x minus 4. But go ahead and graph it. All I'm really looking for is the general shape. I can see that this graph is down on the bottom left and up in the top right, up here. So that would indicate to me that the graph is going to follow the boundary down like this, and up here like this. Okay, that should look similar to what I saw in the picture. There was one last thing. It says you have to state the domain. Now, we didn't really talk about this when we graphed it the first time, at least maybe if you were in my class you didn't. But as you come across, the domain is always about the x's, so I'm concerned about x and what I'm allowed to use. Well, any of these points over here, I can find the graph. The only thing that I'm not allowed to do is use this x value right there, because that's what the vertical boundary does, is it splits it so that I avoid using that value. So I can say that x is any number except 4, and the way I'll say that is x is not equal to 4. You're basically just taking your vertical asymptote and dropping it in as your domain restriction. I didn't go over because I felt like it was pretty straightforward to find that at the end. I wanted to focus on the VA and HA because the VA is the domain restriction. So when we look at question number 4, it's very similar. We start with y equals x minus 5 over x squared plus 3x minus 4. Now you might remember I said over and over again, anytime you have an x squared in an equation, especially the denominator, it's got to get factored. So we're going to go after that before we even worry about trying to graph it. Because we know we need the vertical asymptotes. Okay, the factors of 4 are 4 and 1. To get a positive 3, we'll go plus 4 minus 1. That's a replacement for the denominator. When I go to find the vertical asymptotes and the horizontal asymptotes, the vertical asymptotes are what make the denominator 0. And this is why I needed to factor it. Because there are going to be 2 vertical asymptotes. One's at negative 4 and one's at positive 1. That's what would make each of these spots get me 0 in the parentheses, because a 1 minus 1 is 0. And negative 4 plus 4 is 0. The horizontal asymptotes, if we look at the original problem, it's x squared on bottom and x to the first on top. This is clearly bigger on the bottom. So this is bottom heavy, and all bottom heavy equations have a horizontal asymptote of 0. Now I go to produce the graph. Let's do this one. I'm going to go over to 1. That'd be about right here. There's my vertical asymptote. 2, 1, 2, 3, and 4. Those are my 2 vertical asymptotes. And horizontally, I should be right at 0. Okay. The rest of this I can just grab off of the graph. Now remember, you are not allowed to cross or touch vertical asymptotes. Horizontal ones are acceptable only if the graph says to. I'm going to put this as minus 5. When I do the denominator, I'm going to type in the original problem, which was x squared plus 3x minus 4. And I'll graph that. And hopefully I can see 3 pieces. And I can see these 3 pieces. One of the biggest issues is I need to know that you know what's happening as I come up here. And you should know that you come up and you follow the asymptote, okay? Now, we should have a graph. Whoops. We should have a graph that sits down here like we saw in the picture. There was sort of a U shape in the middle. Now, the graph on the right, technically it does just go up and follow over. But because the top can be made to equal 0, I could use 5 for x and I would get 0. It actually means that over here at 1, 2, 3, 4, I guess that was 1, so this would be 5. Here at 5, I actually cross the asymptote. So if I'm really trying to be good about it, I should have it do this. And then it's going to follow the asymptote on the top side. But I'm going to tell you right now, that, recognizing where that happens, if it even happens at all, I'll give you a bonus point. Okay, if you recognize that it happens. It might not happen, so I'm not making any promises. But those are details that, you know, so often we would probably just draw the curve and say, yeah, it's a sketch, right? So it goes along the asymptote. Well, whether it's positive or negative matters a little bit. Maybe it doesn't matter a ton to the sketch of the graph. But if you can recognize where that happens, great. I'll give you the point for it. But if not, just draw it out the way you traditionally would, and don't worry about it. So those are our graphs. Oh, we need the domain. The domain is that x cannot be negative 4 and 1. those guys right there, become the domain restriction. That's why we draw the vertical asymptotes, is to avoid using those specific values. All right, 5 and 6 are very, very similar. And so number 5 starts with x squared plus x minus 6 over x squared minus 4x plus 4 times x squared plus 2x minus 8 over 3x plus 12. Over here on the other one, we've got x squared plus 5x plus 4 over x squared plus 3x minus 10. Now it says divided by, so I'm going to change it right now to multiplication, and I'm going to flip it. So that's what division does, is we multiply by the reciprocal. That would make it 3x plus 15 over x squared minus 1. And so I'm going to go in and start factoring. All of this stuff needs to be factored. If there's 3 pieces, these x squared equations, I'm expecting 2 sets of parentheses. So I'm going to structurally set this up like that. Now this denominator, notice it doesn't have an x squared, but it does have a common term. So just 1 parenthesis there. I can tell you right now the common term there is 3, which would leave me with x plus 4. Well, as I go through here, I'll just model the factoring process. Factors of 6 that subtract to make 1 would be 3 and 2. Because the 6 is negative, the signs are different. In order to get a positive x, I'll need a plus 3 and a minus 2. On the bottom, factors of 4 that add up to 4 would be 2 and 2. In order to get a positive 4, the signs have to match, but to get a negative 4, when I add, I need negative, negative. Over here, I'm looking at factors of 8 that subtract to make 2. That'd be 4 and 2. And in order to get the signs to work out, I'll go plus 4 and minus 2. So now when I go to cancel things, I notice there's an x minus 2 with an x minus 2. There's an x plus 4 with an x plus 4, and an x minus 2 with an x minus 2. The only thing left on top is x plus 3, and the only thing left on bottom is 3. There's my final answer. Then when we come to question number 6, it's the same thing. As soon as I flipped it, I got the same exact process. So x and x plus 4 plus 1, those multiply to 4 but add up to 5. X and x, factors of 10 that subtract to make 3 would be 5 and 2. And in order to get a positive 3, I'll need a plus 5 and a minus 2. Times. The top just has a GCF of 3, leaving me with x plus 5. And the denominator, that's one of those special factoring patterns I said was so important. You get x plus 1, x minus 1. Now, if I look for common terms, there's an x plus 1 and x plus 1. See an x plus 5 and x plus 5. And I'm stuck, meaning I've got 3 times x plus 4 over x minus 2 times x minus 1. And we are done. So a lot of factoring there. If you can't factor, this is going to be a really challenging section. In fact, I don't know that I know how you would go about doing it without the factoring approach. This is fundamental to what we're doing in this chapter. That takes us to 7. 7 is a unique problem on the back page. On the back page, everything except question 7, the fractions can be somewhat eliminated. We eliminate some of the fractions by multiplication. Here we're not going to eliminate the fractions. We're just going to combine them into one. It says simplify, that's our rule. We have 4x over x minus 8 plus 5 over x. In order to add fractions, we have to have a common denominator. The common denominator cannot be created using subtraction or addition. So this x minus 8 can't be changed. And this x, it can only become something by multiplication. So there's no way to turn the x into an x minus 8. Because of that, it makes the LCD x times x minus 8. Now, in order to make both of them have the same fraction, or the same denominator, I'm going to have to times this side by x, making it 4x squared over x times x minus 8, plus, over here I'm missing the x minus 8. So I'm going to have, if I distribute, 5x minus 40 over x times x minus 8. At this point, they have the same denominator, which means I can combine the top of the two fractions. First thing I ask for, are there any like terms across the top as I look through here? There are none, so I'm just going to push them together to make 4x squared plus 5x minus 40, all of it divided by x times x minus 8. One thing to keep in mind, guys, as we're doing these problems is when you're just adding fractions, you don't get rid of the denominator. Typically, if you add something like 1/3 plus 1/2, you're going to turn them into sixths. So you'll make it 2 over 6 plus 3 over 6. You get 5 over 6. That 6 doesn't go away because all I was doing was adding. The rest of these problems, the LCD is going to go away because we're going to multiply by it in some way, shape, or form. So looking at question number 8, we have 5 over x plus 2 over x minus 1, all divided by 1 over x minus 3 over x minus 1. First thing I see is this negative here. I'm going to make it plus a negative 3. Getting rid of that, I think, is an important piece. The next thing I'm going to look for is the LCD. The LCD for the denominators is an x times an x minus 1. Can you turn every one of them into an x times x minus 1? The answer is yes. This would need an x minus 1. This would need an x. This would need an x minus 1, and this would need an x. That's how I know I have the LCD right. But that's not what we're going to do. We are actually going to multiply by the LCD. X times x minus 1. X times x minus 1. And if we do this correctly, these small fractions inside the big fraction should go away. Because when I distribute this here, this x should cancel with that x. And I'd be left with 5 times x minus 1. Okay? When I go to do the next layer of distribution, this x has been brought back, okay? So it's not really been canceled. It just was canceled for that piece. Now that I do this time I'm going to cancel the x minus 1. But the x and the 2 are still there, so I'll add 2x. Notice the denominator of those two fractions both canceled. Now I'm going to come down here and I'm going to take the same LCD and I'm going to distribute it here. This time the x cancels again. So ignore that x for a minute. I have 1 times x minus 1 plus, okay, this time as I distribute again into here, the x minus 1 will cancel, but this x and the negative 3 are still there, so it's a negative 3x. Obviously I have to do some distribution. I'll get 5x minus 5 plus 2x over, distributing a 1 doesn't do anything, x minus 1 plus a negative 3x. So if I simplify out, I'm going to have 7x minus 5 over, if I combine those, I get negative 2x minus 1. And we are done with that. Okay, so LCD, we multiply the LCD through, it should clean up the fractions, the small fractions. Number 9, similar, except this one we don't actually have to find the LCD. This is 5x over x plus 1 equals negative 2 over x plus 1. I'll put these in parentheses. And this is going to be a traditional cross multiply problem. 5x times x plus 1 should be 5x squared plus 5x. That's from this first multiplication here. Okay? Then I have negative 2 times x plus 1. That's negative 2x minus 2. I put the parentheses in the problem so I would remember to distribute. Now, do you notice the x squared right there? That tells me it's quadratic in nature, and to solve it, I need it equal to 0. So I'm going to start by bringing everything over. 5x squared, I'm going to add 2x to get 7x, and I'm going to add 2 to get plus 2 equals 0. I'm going to promise you these things will factor. Because my goal was really up here in this stage. Do you understand the structure of how to solve it? They should factor pretty cleanly. When I have to go 5x and x, and this is what some people struggle. They don't really think their way through this process. They see, oh, 2 doesn't split to give me 7. But remember, this 5 over here, it's going to help us out. So we've got to think, where do we put the 5, where do we put the 2, where do we put the 1? Because 2 splits as 2 and 1. I'm going to put the 2 here and the 1 here. Notice all the signs are pluses. Now we need to check. This right here is 2x, and this right here is 5x, which is how I know I'll get the 7x. So this is correct. I just need to solve for x. Well, from over here, I'd say it's -1. And then from over here, we've got to remember, it's -2. We have to remember to divide by 5. So those are my two answers. But I have to check them. You remember how we had the domain restriction on the graphs that said we couldn't use certain x's? The same rule applies here. If I take -1 and plug it into this right here, I would get -1 minus 1, which would equal 0, which means the -1 has to be rejected. The -2/5, I could check it and it would work just fine. So we're just confirming that the denominator doesn't become 0. And number 10, last but not least, yeah, x over x minus 4 equals 4 over x plus 4 over x minus 4. This is again one where, because of the equal sign, and I'm not just adding, I'm actually solving. Because of the equal sign, if I can find the LCD, I can multiply through by the LCD and destroy all the fractions, get rid of all of them. If I look through here, I see an x and I see an x minus 4. Sometimes you think about the LCD in terms of, would everything cancel one at a time? The answer should be yes. If I times by x times x minus 4, let's take the first distribution right to here. This x minus 4 would cancel this x minus 4 over here. And I'd be left with x times x, or x squared. Then if I distribute it to here, this x would cancel with this x, and I'd be left with 4 times x minus 4. Okay. Then, on this last one, last distribution, the x minus 4 would cancel the x minus 4. This x is still there, times 4 becomes 4x. I see that I have a quadratic because the x is squared, so I need it equal to 0. I also need to do this distribution while I'm at it. So this is really x squared equals 4x minus 16 plus 4x. So I'm going to pull all that stuff over. This 2 right here is 8x, so I'm going to have x squared minus 8x, because I'll subtract it over, plus 16 equals 0. So I can add the 16 over. Now I go ahead and I set up my parentheses. I have x and x minus 4 minus 4. They multiply to 16. They add to -8. So I only really have one answer. It looks like 2, but really my only answer is 4. But I have to check that back against the original problem. And if you look in both of these, if I used 4, 4 minus 4 would equal 0, which is not an okay thing. So I actually have to reject that answer. And because I don't have another answer left, I say that there's no solution. The only solution was a bad solution, so there's just no way around it. All right, good luck. I really hope that helps. You've got to come to class asking your questions, though, so please do that, and we'll see you in class.